This is a simple schematic of the Miele C3 vacuum cleaner that I describe in a video that goes alongside this, and others have shown to great effect on YouTube by demonstrating how to take the unit apart and how to repair it. What no video or teardown that I've seen to date actually shows you is the circuit flow and the supply through the unit to help you understand where you might test the vacuum cleaner and determine where a fault might be in trying to carry out a repair. So what I've done is put together this little schematic, and it's basically three elements. One is the reel housing, obviously where the main supply comes in. It's obviously on a reel, and then with two pins goes on to the control PCB and on-off switch, and then from there it goes on to the motor housing, and where the motor, along with the triac and thermal cutout module, which is actually inside the motor itself. If we take a step back, you'll notice that it's all done with very well engineered connector blocks, but it does show that in the end what you have is the blue, the neutral line, is continuous and goes from the AC supply, loops through the control PCB and then onto the motor. The only use of the triac and thermal cutout module is to actually provide connector pins to the motor itself. Then you have shown in black on this drawing, and indeed in the unit itself. It's against the normal convention, certainly in the UK, because we tend to use brown for live, but that would confuse things because Miele used brown for the trigger for the gate control supply. But essentially the supply comes in, and it again goes up to the control panel unit, and that's where you'll find the on-off switch, which often is a culprit in repairs, but in the one I was doing it was fine. It's a very simple on-off switch on the top panel alongside the PCB. The PCB is actually underneath the panel because it's got a series of LEDs to show the status of the vacuum. So simple on-off switch on that supply, so it's not isolated, it's just on the what we call the live side, and that also loops through onto the control panel and then onto pin 2 of the triac module, and it is that supply that is switched on and off by the gate on pin 3, providing power to the motor. The control panel sitting underneath the top panel of the Miele unit is then just has several functions. One is to enable the control to send a signal to the gate, varying that intensity so that the motor will run slower or faster according to the setting on the panel. And indeed, this is one of the places where things can go wrong. So the three main culprits electrically of what can go wrong: obviously you've got to check that the supply is coming into the unit on the pins on the reel. Once you've checked that, obviously you're checking a mains fuse as well. You've then got the on-off switch, which clearly overuse can go a bit soft and not make a good connector. And then you've got the fact whether the motor itself will work, and that means what you have to do is somehow put a mains voltage across the motor, because it is a 240 volts unit, but because it is well hidden, the supply to it inside the triac module, it's a bit awkward to do that. But essentially you can, with the motor out, you can actually test the triac because you've got the pins on the side of the motor which will enable you to test the 3 pins of the triac. So if you've satisfied yourself that that's okay, similarly if you then go on to take out the triac to just check if the thermal cutout it has gone wrong, and of course you'll know because you'll see an open circuit if you put a meter across it. But essentially the control PCB's main function is to, with the main supply coming into it, is to actually control the voltage, or sorry, control the power to the motor, the control gate to the motor. So I hope that helps. It's a fairly simple idea, but might actually help you in working out which bits go where and how they all work in looking at the circuit diagram and testing points on the Miele vacuum cleaner.